Hey everyone, welcome back. Today we're going to be taking a look at my implementation of the MTA's train time system, Realtime and TouchDesigner. So that's the New York City subway transit lines. And so through this project, we're going to be taking a look at how we can get that data inside of TouchDesigner and build some pretty nice, elegant visualizers that are also very informative and give usable information to anybody who happens to be looking at them. So I'm going to be doing something a little bit different today, and that's because I don't want this tutorial to be too boring and kind of focused on the data analysis side of things and kind of doing a lot of the, let's say, unglamorous setup work required. So I'm going to basically just wrap up this project file as is and include this on my Patreon. And I'm going to be just kind of talking through it in this tutorial, going through the different components and structures, and focusing a bit more on the infrastructure, how each of the different pieces works together, and how it all kind of adds up to a final result that is what you're seeing in front of you. So with that said, we can take a look at what we are going to be diving into, and that is the ability to choose any route and then have these stations auto-populate based on the route selected. So if I choose, let's say, an L train, then there are stops that occur on the L train that appear. If we go back to the F, then we have completely different set of stops. And you'll notice that this is also color-coded based on the train colors. And it's a little bit hard to see with my fluid visualizer, but I am also plotting the different routes and labeling those routes in the background, which is just another little touch and some nice functionality that I think brings everything together in an aesthetically memorable way that also links it with the subway signs that at least New Yorkers are used to seeing all over the place. So first things first, where do we actually get this data? And thankfully, this wonderful fellow has taken the time to put together this MTA Realtime API JSON proxy, which essentially just takes the MTA's real-time subway feed, which is in its protocol buffer format, which is kind of weird, and does a little bit of the processing for us and gives us a local server with a JSON formatted endpoint that we can just go and access the data from. So it makes our lives a lot easier. Now, what you'll need to do to access this server and get it all set up, we will jump into in just 1 second. So you'll need an API key, which will be, I believe, yes, you can get here. Just sign up for an API key, and then we can just go ahead and copy this URL, and then I'm going to open, I'm going to open VS Code. I have a new version of VS Code. Then I'm going to open a folder, and I'm just going to create a new folder here. Call this live, and then I will select that folder. And now this is open in our Visual Studio environment. So at this point, I'll open a terminal here, and I will launch a git bash. So here here you can see that we are already in this MTA live folder, and so I will just git clone this entire repository, and it will be cloned right into this folder. And then I can see that my MTAPI here exists. So your settings, you'll just change this to settings.config, removing the .sample at the end. All of this can pretty much stay the same, except your API key should obviously go here. So let me get my API key. There we go. And now we should see that we can just use the command python app.py. Whoops. So no need for git bash anymore. And then we can actually just cd into that MTAPI, and then we can use dir to look at all of our different options here. The README file is also the same README as what is on his GitHub, so that's nice because we can kind of just use this to figure out what we need to do. So, create a settings.config file with our API key. Done. Okay, great. Set up a environment and install dependencies. Okay, so we should probably do that next. And so we have this PowerShell. So what we can do is actually just kind of copy these commands. And we'll just run them in our terminal because our terminal is in the same directory as everything else right now. So we will set up this virtual environment. Then we will activate. Actually, I think we can just say python activate venv. Okay, so now we will just run, so just clear, okay. Alright, so now we will just start running these commands and we'll set up all of our Python. So python -m venv.venv, there we go. And now we can skip that activation and we can just go right to python -m pip install, and then we'll use requirements.txt. Now, if you have some issues here, you may need to install Flask using pip install Flask. I already have Flask, so I don't have errors, but when I did set this up on my computer the first time, I needed to use that command. And then after I used that command, I was able to actually go through and do the txt requirement file. And so now that that is all set up, we can take a look at this again, and we'll look at that app.py. So we'll just try and call python app.py. And now we'll see that this is indeed running, and it's running on a local server. So we can then just pop into our local server, and we can see that indeed our API is running. Now we need to do something with this API and actually be able to get some data with it. And so for that, we can use this endpoint documentation that he has included. And this is what I use to basically write the TouchDesigner extension that parses all this data and outputs the arrival times for specific routes and stations. But it's very important to understand if you want to get deeper and kind of do any more lower level programming yourself. So this endpoint outlines how you can look up stations by location, meaning latitude and longitude. You can look up routes by route. That's just using like F or 6. You can also look up by station ID, which is unique identifiers based on each station. And then you can get a list of all available routes. So for example, if we just do this and go to routes, we can see all the different routes that are available to us. So now if we search by route, and I'm here just using the address bar to navigate through the different API endpoints by addressing them directly. And then this is exactly the same thing that we do inside the TouchDesigner Python extension, just programmatically. So you can see here, this is basically a very dense, hard to really see what's going on list of a bunch of different stuff. But the important thing is that we have different routes and different stations with different arrival times. And so the last thing that I want to show, and actually it's a little bit easier, I think, to see if we go and look at his endpoint documentation. So if we look at by location, we can see an example of the data that's returned if you search by station as well. And so that is a list of routes, the northbound routes, or sorry, a list of arrivals. First, the northbound arrivals stratified by line or route, a list of southbound arrivals, the station ID, the station location in latitude and longitude, the station's regular old name, the routes or lines that go through the station, and then this stops dictionary is how he's handling if a single station has service through multiple stops or multiple lines. For example, like when the ACE and the BDFM both go through the same station, they will have different IDs for each route. So this stops just kind of aggregates all of the IDs for a given station together. And so with all of that information, we can basically just use our route to then say, okay, I want to look at all the stations on this route using this function, return all the stations provided on the route. And then, so we have a route, we pick a route, and then we can pick all of the stations on the route, and then we pick a station. And then we can see whether they have northbound or southbound arrivals or both, and what those arrival times are. And so all of that information is just extracted from JSON API responses that we get using this URL. So that is the basic setup of the actual API itself, and now we are running it on a local server. I'll be honest, I don't understand everything that's going on under the hood here. I don't think it is essential. I think the more important thing is being able to understand what you need to do to use the tools other people have built. And so that is, again, the goal here. Now, we have this data working, and the one thing that is important is that this local server needs to be running all of the time in order for our MTA visualizer to work at all. So that is why it's helpful to run it in a separate process. Now, right now I'm running it in my VS Code terminal, but if I close that and we see you can also just run this in a completely separate command prompt and just run that Python app by itself. So I will just open a fresh command prompt, and then I will cd to where I need to go. Oops. And then I believe I called it live. Okay. And so now we can just cd into our MTAPI, and now I can just call python app.py, and there we go. All right, so now that we've got our Python app running locally and in a separate process outside of TouchDesigner, then again, we can go just using a browser and navigate to the endpoint provided by the server, and then we can see all of our data. Now, at this point, I think I'm just going to start giving a tour of the project that I've built and kind of how it's structured. Again, the purpose of this is to more illustrate how you can use some of these API methods in conjunction with some other techniques to create more complex projects and interconnected systems. So with that said, I'm going to start in just this MTAPI component, and without going through the extension, I'm going to talk about some of the other stuff going on here. So the main kind of feature of this component is that you can select by route, and then you can have these stations automatically updated based on the route and an auto update. So that functionality is actually much easier to implement than you would think, and by that I mean dynamically calculated menu sources actually just requires this little text stat, which will basically create a little label structure out of any table dat. So you can point this dat menu, menu names, and we can point this at any table, such as this table, and the name and label columns, as long as there's a column in the table with name and label, those names and labels will be used for the name and label of the menu source. So that's what I'm doing for both route and station. I have this route table here that's updated once via the API, or really via the extension that uses data from the API. And we'll take a look at that in just a second. I'll open it up and get it ready. That is unimportant. So that is kind of the secret, and I got this from the forum. I think Rob from Derivative put together this little example menu, and so it's really handy. You can see that in my menu source, in my component editor right here, I am creating this menu source with just a little bit of Python, and that is looking at the dat menu module text stat. So that's just literally this text stat dot module dot dat menu. So now we're at this class, right? So we're accessing this class from this little module that we're creating, and then we are essentially creating a new instance of this class, and we're doing that by passing a path through the initialization function. And that path in this case is going to be stations on route, which is this table that includes the name and station index for each station on a given route. And so the last thing to note is that that path is relative to the dat menu module text stat, not to the component itself. Now on the route, I do the exact same thing. I'm just using this routes table, which is the one that I showed you already. And both of these are created again on every update via the extension. So maybe it's a good time to take a look at the extension so that we can understand a little bit more about what's going on under the hood. So I'm not going to go through the basics of generally extensions, but what this extension is doing is providing a bunch of different functions for connecting to this local API and accessing data from it. So for example, there's some utilities like minutes from timestamp, minutes to timestamp, etc. I went through and hard-coded all of the different MTA route color codes using a source I found online, and then created this little function to grab the RGB color of any route, which is how I then have these routes that change based on the color, or sorry, the colors that change based on the route, rather. Here, there's a couple of different lookup functions to look up by route or by station. You can see we're literally just doing some f-string work here by substituting in our selected station into the URL, and then we're just grabbing the entire response from that URL. This stations on route function, this is where a lot of the heavy lifting is coming in. So here I'm basically going, for every route that's selected, loop through all of the stations on that route and extract their pertinent information, their name, their location, their station ID for lookup. And through this function, I also get all of the data that I need to then populate this stations on route table, which I don't actually do in this function because we want to keep things modular, but I do have another function down here called update station menu table that calculates that stations on route and appends rows onto this table with all of the interesting important information that we need, and that is called on update. So that's how we update the stations on route every time this route changes. The only missing piece, and you might be asking, is how do you know when to call that function and how does it do it every time this parameter changes? That's actually a really easy part using TouchDesigner, and for that we just use a parameter execute dat. I have both the route and update parameters in here as a target parameter, and when the value changes, we're going to update the station menu table. So that means that when the route value changes, then our extension is calling this update station menu table, which repopulates this table, which you can see happening there, repopulates that table automatically. Oh, the S is a weird one. And so we're doing that whenever the route is changed. We are also doing it whenever it is updated, because you never know if for whatever reason some stations change in between updates. We're using a similar par execute for the actual updating itself. So here is very simple. We simply, on the change or pulse of any of these parameters, we just call our update function, which is also from our extension, and basically just goes through and does all of the needed logic to call a new hit from the API and parse the data. You will remember from looking at the endpoint documentation, which I think might be in here. Yes, the endpoint documentation, that we get both northbound and southbound. So some of my extensions take for arguments directions. So you can specify northbound or southbound, but as I have it built, I'm just grabbing all of the northbound arrivals and all of the southbound arrivals and concatenating that together so that you can see both the north and southbound arrivals for a specific line at a specific station. So that is most of what's going on here in this extension. If there's interest or it's helpful, I'm willing to do a full tutorial kind of going through this extension and the data analysis part of it in more depth, but I'm going to hold off on that unless there is some desire. So let me know, and I can definitely do that, but I'm going to keep it here for now, I think, because I don't want to get to be too boring. So with that said, the par execute and that little dat menu module menu source is really the secret sauce behind what's going on in this component. The only other thing I have is just this little timer that on done hits our update, and that's how we do the auto update every blank seconds, which should not be very surprising. So that's how we get our data, and so now we have northbound trains, southbound trains arriving at a given station in X number of minutes. Now, in the configuration settings, you can change the number of trains and the max minutes in the future that you want results returned for. So, for example, because the M train and Delancey Essex Street is a station that has several different stops and different train lines that come through it, that maximum number of trains is spread across the arrivals from every route at a given station, which means that if you have a station that has several routes or lines coming into it, you might only get 1 or 2 returns for a given direction for a given line, because there are just too many trains. Like Union Square is a good example. I think I can probably pull that up here because it's on the M. or like 34th Street is also a good one. So there's only two for the M because 34th Street is a very busy station and has like, I don't know, 8 or 9 lines or something in it. And that is why there's only 2 results for the M train coming up, because there was just enough trains that only 2 each got to that level of 25, which was the configuration threshold. So that's why only a couple results show up sometimes. But if I go to, let's say, the L train and a stop that I know only has L trains at it, then we can see that we have arrivals up to 4 in the future. And again, that's just kind of set between the configuration saying only go, where's that? The configuration saying only go 30 minutes into the future. And then my own choice in display to just display only 4 arrivals. So with that, we can jump into the rendering of the stations. And the only thing I want to point out before this is that in the data that you get from downloading or cloning that GitHub repository, you get the settings.csv file, or sorry, stations.csv file. And so stations.csv, I actually am just pulling in here as a file in. And then I'm grabbing the latitude and the longitude out of this data. So this is essentially the lat and lon of every station in the MTA. And then I'm using a limit to just normalize those to -1 to 1. And then I am just instancing those points to render them out. So if I perhaps bypass this little fluid visualize addition, so we can see just the points there. And I will also show just this. And so we can see here a little bit more clearly what's going on. So we have each little white dot, which is every station, and then the larger color-coded dots with the logos are written over top of the stations based on the selected route. That selected route is simply selecting that stations table from the API component, grabbing the X and Y values, which I calculate in the extension, doing this. So just using the latitude and longitude of the station in the loop to create these normalized X and Y coordinates, using the maximum latitude and longitude for all of the stations as a normalize, which is, by the way, exactly what's happening in this limit. So essentially we're normalizing the active station routes, or the active route stations, by the same function that we're normalizing all of the stations, so that they overlap exactly, and we can just write them over top. Because this also changes every time I change the route selection, it's great because we don't have to do anything else to change this rendering as our selected stations are changing. The last thing I did was just add a little logo to make the visualization a little bit nicer and color-coded. So I'm grabbing the route, just using the parameter of route selection. I'm using the Helvetica font, which I grabbed from Google Fonts online somewhere, because that's what the MTA uses. And then this is super simple, just putting this F over a circle, flipping it because I'm flipping my render, and then taking the fill color of the circle from the MTA route color, which again is something that I am just looking up every time we update, and setting this parameter value via extension using those hex codes that I hard coded. And so in that way, we get this nice color-coded visualization that plots out the route of interest along all of the other MTA stations. Now, you could definitely add a shapefile or something to kind of draw the outline of Manhattan. That wouldn't be too crazy. If you have the latitude and longitude in that shapefile, you could, in theory, normalize that using the same normalization function that we're using for the X and Y. Specifically, you could use this map location to XY function in the extension because it expects latitude and longitude that is within the bounds of these, it expects a latitude and longitude that is within the bounds of the maximum latitude and longitude for all of the MTA stations. And so that's about it for the render. I just threw a fluid component on the front of it because I thought that it added some real nice ambiance, but that is obviously not necessary. And if you guys are interested, I'm just going to include this fluid simulation in the project file on my Patreon. The last little piece here is just this display overlay, which is not terribly complicated. I'm taking very similar, just a text using the route. Here I'm using Helvetica Bold, and then just kind of recreating that little logo. Another text stat with just the selected station. And in this case, I'm actually using an an extension function in my expression here to look up the name from the station ID, and in that way having my text automatically updating as well. Just a quick little layout, just put these beside each other, and then I have just a couple labels. This is all not terribly scalable because I pretty much just hard-coded this little visualization together, just like using the translate here in the over to positions northbound and southbound. And then here I am selecting the northbound and southbound arrivals for this selected route and station, and that's just again selecting these stats from inside of the other component. And then for each of them, it's exactly the same. I just have 4 text stats. I limit this to the top 4 rows, and then I grab each of those rows for the text. I have this little expression in here, which will just make them none. And here, let me look at these parameters. And now I have this little expression, which if there are not enough entries, instead of having the card filled with something like none, for example, it is just filled with blank. So if I didn't have this, it would say none when this expression returned a value of none. I didn't want that. So this is a little one-liner Python to just replace that with an empty string. And that's what gives us these empty cards. I then just have a little rectangle, like literally just a rectangle that goes over the top, that is both background and the little white outline. And then I'm just laying all of those out, stacking them up, and then using these overs to overlay. And that's it. That is the entire overlay visualization and the route rendering, and also the API data collection, extension, and automatic parameter updating, which is pretty much the entire functionality of this project inside of TouchDesigner. So feel free to hit me with some questions if there's anything that I missed, or if you go through the project file and find something that doesn't make sense. Certainly happy to help there. The one thing that I want to note before I go is how I start up this project. And I start up this project by using this bat file. Now, you may be familiar with bat files, and I'm just going to exit this so that I can restart the entire thing from scratch. What a bat file does is just execute command line commands for you. So you can click on, let's say, just this bat file, and I will do that actually here. I'll just click on the bat file, double click it like you would a program, and on my other screen, this monitor command prompt just opened up and ran those commands. So you see it ran start mtaviz.tow, which is the TouchDesigner project, which again obviously started on the other screen, but here it is. and then change directories into the specific MTAPI directory, and then started our Python app for us. And all of this happened automatically at the same time as our TouchDesigner project was being opened, which is phenomenal. And I think that's really helpful when you're running something like a local server in a separate process that needs to be started at the same time, or even before in some cases. So if you wanted this to, let's say, start at startup, you could just create a little shortcut to this startup bat in your startup shortcut directory, and or in task scheduler, and either of those things would then allow you to just run a bat file, which is the same thing as running a set of command line operations on start, and that will open up your project in exactly the configuration that you're interested in. So I just wanted to call that out as well because I think it's a good example. It's a pretty simple example of this use case, but is certainly a very scalable and extensible technique and worth knowing about. So I hope this wasn't too long, and I am interested if there's feedback on kind of this format where it's more like talking through some techniques and trying to cover more ground in less time. Certainly let me know if this is good or if y'all hate it. That would be helpful to know as well. And for anybody still listening, thank you so much for the support. And until next time, I wish you all the very best.